Welcome, and I will be starting shortly. Welcome to another episode of Microcontrollers with kingernorth. That's me, I'm kingernorth, and I will be hosting you for about 1 hour. This is episode 13, controlling DC motors with CircuitPython and Arduino. So let's just get rid of our starting soon scroll. There we go. So welcome again to all those people that aren't here yet. Hey, it looks like somebody's here. Good morning, Walter. Welcome to the stream. Yeah, we're going to be looking at this controlling DC motors with CircuitPython and Arduino, and we're going to cover a fair bit in this little short time, and you're going to see how easy it can be. It can get more complicated if you wish, but let's just have a look at what we're going to be using today. So, here's a view of the different parts we're going to be looking at, and I'm going to be showing you some features on some of them, and some of them I'll actually be using. So to start out with, we got a couple of motors here. There's a wheel mounted on this one. There's just a little end on this one. I've done nothing more than mount them on a block of wood, and there's the motor there in yellow underneath. So we can tip it up this way. You can see that it's there. I'll show you that in more detail. But that's our basic motors, and we're going to be looking at those small DC motors and doing something with them just to make them move, and we're going to talk about how we control that. Then there's different ways of controlling it. Of course, we have our Uno up here. This is our Uno. I'm not using the one with the breadboard attached because I put the circuit in the middle here on this breadboard. We also have the Adafruit Feather M4 Express. So we're going to be able to use that as well for the CircuitPython programming. Of course, the Uno is used for the Arduino programming. And I'm going to talk about a couple of other things, and I just wanted to show a couple of other boards that are available. Over here, for instance, this is another CircuitPython controller board here. This one actually has Bluetooth attached to it, so we could do some things with it. But it's basically another version of the M4 Express. But it's mounted to this thing called a Cricket. And this Cricket is nothing more than what they refer to as a daughter board. Basically, what happens here is that you end up with a connection through here, and then this can drive and can connect to many other devices. And actually over here, this connector here is eligible to hook up two motors, two DC motors if you want, or a single stepper motor can be connected to this side. So it already has the drivers and the chips and everything built into it to assist you, and we'll go over that in a little bit. But that's one of the boards, so let me move that one out of the way. And oh, there we go, we're caught up again. All right, this other board over here on this side, this plugs in. It's designed, it's got pins on the back, and it's designed to plug in right on top of an Arduino Uno. Now this is a pre-made board, but it has a motor driver connected to it as well, and there's actually motor leads connect onto here, and you have to get the information. This one says motor shield, and there's lots of different versions of this out there. Okay, so this is what can happen. It looks like I might be dropping the odd frame, but we'll just persevere through and see how this works. So that's another board that you could use to hook up a motor, but that's a commercial board that you'd have to buy. Just like the Cricket was a commercial board. Other items you can use for controlling a motor, let me move these motors out of the way for the moment, is something as simple as this. This is a relay pack. So there's two relays on here. We have some pretty big screw terminals here to connect heavier devices to, like the motor, things like that. And on this side we have a bunch of pins, and these connect back to the boards to run it from the microcontroller board itself. These are available online. You can buy these from a number of sources, including eBay, as well as any of the electronic suppliers usually carry these as well. And these are pre-mounted to a board, and they have a bunch of stuff already built into them, a bunch of chips, and that allows us to do a few things that we couldn't do otherwise. Okay, so I see I am dropping a few frames on my image today. I don't know why. There shouldn't be anything running in the background. You never know with Microsoft, so I'm just going to check one thing because Microsoft did a big update this week, in case you didn't realize. And I'm just going to see if something's running in the background that I told not to run. There's so many things that run in the background, it's hard to believe everything that's on here. But anyways, it looks like... No, it looks like we're probably okay. Okay, not quite sure then why I'm dropping frames, but we are. I'm not going to worry about it too much. It's only going to cause a little bit of freezing, but hopefully you're hearing things just fine. Okay. Oh. Yeah, that YouTube is, it is dropping frames. Okay. This is a relay, just like what's on the other board there, except this is a standalone relay. And this one you would have to do all the hookup to it. It's got pins on the bottom. This one happens to line up so it fits on one of these little perforated boards here. You could do that, and you could utilize that. So, there it is there. And let's see what else is happening here. Yeah, everything looks okay there. All right. So these are our boards. This one's already plugged in, but I'm going to put it off to the side. That's the CircuitPython board. And here's our control board that we're going to be using today. And this is, we're going to tie this in with the Arduino. So I'm actually going to turn this one around just because it's going to be a little bit easier. And I'll put this on this side. I already have wires connected here, but let me show you what we're going to connect. So we're going to go over to the main page now, and I'm going to show you what we're going to be wiring up here. So on our main page here, let me show you that diagram because I want to show you what we're doing today. So this is your basic circuit for a motor controller. This is as simple gets. And we're building something basically like this right here. So what we have on here, and let me move my mouse up onto the screen here. Here's our motor. This is just representative of a small voltage motor. Typically, these can be anything from 5 volts, sometimes even a little less. And they can go up a little bit higher, too. You can see on this drawing here, they say up to 60. That's going to depend on your transistor that you're using here. But the idea is on the left-hand side here is you bring your own power source in here. So it's not drawing power from the Uno itself. We don't want to draw power for a motor through these digital pins down here. These digital pins really can't handle the current of the motor, and there is protection that we need to supply so we don't damage our controller boards. In here we put a transistor in here. This one happens to be a tip 120. The one we're using today is basically just a P2N2222, a very simple NPN transistor. Nothing fancy about it. I'll point it out when we show you the board. And over here, we have this little item right here underneath the motor connected, and it is a diode. And that diode is on there, and this is very important to have. And this is whether you're going to put on something like a relay or a motor or anything that the device has a coil in it. So if you want to add an electromagnet down here, it has a coil in it. What happens in electricity is when you power this up and you turn it on through the switch and it comes back to ground, is what it does. What happens here is you end up creating a strong magnetic field, and you're doing it electrically. What happens is when you release the power, in other words, when you shut this off, all this energy that's used to create the magnetic field has to go somewhere. So what it does, it collapses. And what it does, it puts up a reverse voltage. It actually puts voltage in the opposite direction. The problem is that the voltage could be up to 3 times higher than what the supply was. So if you supplied it with 5 volts in theory, it could be as high as 15 volts coming out, but in the opposite polarity. You don't want to put that kind of voltage into your controller board. That would be bad for it. Seeing that high of a voltage in a reverse direction, not good. So we actually isolate it by using this transistor, and then that way we can use an external power supply anytime we're doing anything with coils. And you should try to do this whether you're using relays or you're using motors, electromagnets, solenoids, anything along that line, you should try to use an external power for controlling them. To trigger the transistor, in most cases, and this is all this is just a fancy transistor. To use this in most cases, what we do is there's different types of transistors out there. There's lots of different families of transistors. A standard NPN or PNP transistor will do the job usually. And the nice thing with them is they just require a small amount of current coming in here, either current or voltage, depending on which one you have. This is current limiting. We're actually using a resistor here to limit our current. We're putting in a little bit in here, and it comes back to ground. And if you notice, the ground from our power supply externally is connected to the ground of our Arduino. So that's important that you do connect the power back. So that ground wire has to be connected through. This gives me a completed circuit. When I leave this pin, go through the resistor, I go up here. This is connected to the base in this case. It allows, and basically is an electronic switch that allows these two to conduct electricity between them, the C and the E, the collector and the emitter pins. And then what that does is complete the circuit for the motor, so the motor runs. And I'll show you, we'll actually do that. But don't forget this diode. This diode is very important to protect everything else. So keep that in mind when you're doing it. You want to add a diode in there, and I'll show you where that is on my board as well. It doesn't have to be usually very big. It'll depend on the size of your coil, how big that diode needs to be. But that's your basic circuit. There is a second circuit out there. This is the one we're going to use, but let me show you what the second circuit looks like, because this one has some limitations. You notice that we're only putting it on, and the positive only goes to one lead of the motor. That means this motor is going to turn the same direction every time. Yeah, okay, let me see if I can figure out what's going on here. It has a little diagnostic help with the program. So for some reason it looks like it may just be a bandwidth problem, and that would be with my supplier. I'm going to see if I can make a little change on the fly here. I don't know if it will help me with this or not. And if I can do that, I'm using 30 frames per second. It seems to be happy at the moment. I'm hoping it's sounding okay now. It doesn't tell me that it's dropping frames at the moment. And you gotta hate this when things happen on the fly. And this is what happens with live connections. Sometimes you end up with things happening at the time. Okay, I don't think I can change these settings while we're running, and I really don't want to stop the stream to do it. My resolution is good, my frame rate is good. Alright, well, let's see if we can continue going through. So it was garbled. Let me just check on that. This is going to be tricky because I might get a little bit of feedback. So it was garbled. Let me just check on that. Yeah, it does appear to be very garbled. Okay. So this is interesting here. I'm not knowing why. I may have to stop the stream, and then what I can do is restart it very quickly and see if that fixes it. And let me just do that. So we'll go back to our opening screen, and we'll see if this works. So bear with me. You might have to restart the stream, go back to my site, and I will make sure that the final one gets put onto the site properly. So I'm just checking now to see if it restarted, and it looks like it did. Is that sound any better for you, Walter? We're testing it. We're going to try from there. So very quickly, I'll run through the very first part again without quite everything in it. This is Microcontrollers with KingerNorth, episode 13. Since it's a new stream, we're restreaming because we had some dropped issues. And this is controlling DC motors with CircuitPython and Arduino. Now, I'm not going to go through everything, my camera zoom. I'm going to start with my Arduino board, and we're going to go through things quickly here. So let me go to my main screen. And I'm going to pull up that picture again that I had up there for those of you that did see it. This is our basic circuit. So this is our basic circuit, our Uno, our transistor, a basic transistor, but lots of different types out there, and a motor. The big thing I was talking about here is we use an external supply to power this. We use a diode, and this diode is for any time you connect a heavier load, which a motor is a heavier load, an electromagnet, a relay, a solenoid, anything along that line. This creates a magnetic field in here. When you turn the power off to it from the source, this actually collapses and it produces a voltage of up to 3 times as high as what it was supplied. So if we supply 5 volts in, it could supply as much as 15 volts out. And what happens here is that this diode is connected in what we refer to as reverse bias. In other words, the negative lead is connected to the positive side is connected to the negative, and this will absorb that extra power and let it dissipate very quickly through itself and protect everything else, because we want to protect our microcontrollers. Also, the reason why we use a transistor, which is like a solid state switch, allows us to connect an external voltage and even possibly a different voltage than what your board can supply. In this, most transistors require something like a resistor, in this case, to do current limiting. There's also voltage ones in here that require a certain voltage to power up, so you just have to check with the specifications for the transistor you're using. For today's, this particular drawing shows a tip 120. You could just as easily use the one we're using today, which is a P2N2222. Very simple NPN transistor. So that's what we're using. So that's where we're going to take it from there. So let's get out of there and let's go to our actual board and look at the components on it. So we're just going to zoom in a little bit here. And in fact, I'm going to zoom up one spot here just to show you what I've got. So here's my Uno. I'm going to go ahead and plug it in. So that's my Uno connected there. What I've got here is I have 3 wires that I'm going to be hooking up. We don't necessarily need 3, but I'm going to take power from the Uno, plug it into this board, and there's the important ground connection. So this black wire is the ground connection that connects this to what's going to be this external supply here. Up here, I've got a jack connected. And we're going to bring in an external power supply. And I have one here. This is just a simple little 5-volt supply externally, so I'm going to plug that in. And now I'm supplying external power to this rail out here. And on this side, I'm using the Arduino power on this pair of wires. So this Arduino power is being used for a couple of things. One, it's going to be used for this yellow wire here, which is our push button. We're going to use that to turn the motor on and off. I have a green wire connected here. This green wire is connected to the pot. That's going to give me a variable voltage so I can adjust the speed of the motor. And then finally over here we have a white wire, which is right here, which is going to be that signal wire that feeds my transistor. And going to it, there's my resistor that's in series with my little transistor, and that's all it is there. It's a little tiny thing. And then over here is the diode. Move that white wire out of the way. You can see there's a diode there, and it's small. But it doesn't have to be very big. These aren't big motors. What I showed earlier, and I am going to have to zoom out. So now that we looked at the board, I'm going to zoom out to show you the rest of the connections. Because as I move this over here, I want to bring my motors in here. In fact, yeah, I'm going to leave it in, which direction can I put it in that? Will it fit in that direction? I think it will. I think we can squeeze all this on the screen. So there's my basic motors. I have two different versions here. Both motors have red and black wires connected to them at the back. This one's connected underneath, but it's still connected to the motor. I'm going to take the red wire and I'm going to hook it up on the one side of the diode that's got the red wire connected to it. You can see this red wire here goes through to there. And I'm going to take the black wire and I'm going to connect it to the black wire side. And if I do this, because this is 5 volts, I could take this lead here from my transistor without any programming, connect it to my 5 volts from my Arduino, and that little motor up here in the corner runs. And you can see that it spins and it stops. So it's pretty good. Sound is failing again. Okay, oh boy. You can see that it spins and it stops. Is the, well, it's better again. Okay, I'm not sure what to do about that today, Walter. I think we're going to have to suffer through sound. Who knows? Maybe my computer's doing another update in the background and isn't telling me. You gotta love Windows. Okay, so what we're going to do is let's build this Arduino program. So let's go to my main screen and let's build a basic Arduino program. We don't want to hesitate any longer. We want to get this working. There we go. There's my Arduino Sketch that we're going to be working with in here. So this is a brand new file. So first thing I'm going to do is I'm going to go File, Save As. And we're going to put this in here, and I'm going to put this, let's see, Documents, Electronic Show, Episode 13. And in here, I already have one in here for Motor 1, so let's give this a slightly different name and just call it M1. We're going to go with a really short name today. And I'm going to hit Save. So this is called M1, and there it is up in the corner. Little tiny print, it says M1. So the first thing we're going to do is we're going to add some code. So let's go ahead and put in some code. I always like to start with a comment. So this is M1 by kingernorth. So hopefully you can just follow along as we're going along in case the sound drops out. I'm not sure if it's going to stay or not. It's just one of those days. And basically what this is a demo to control DC motor. And that's what we're doing today. We're keeping it really simple. We're just going to control a DC motor. There are no helper files in Arduino, so we're not going to put those in. But what I am going to include is I'm going to have to declare any pins and variables needed. And we are going to need some in this program. So let's just make some room here. So the first thing I want to do is I want to hook up this white wire over here, and I want it to connect to something. So I'm going to need something for the motor. So we're going to create just a pin for that. So we're just going to call it motor 1, and we're going to make that equal to pin 9. And that's as simple as we get there. I also talked about I have 2 other devices for inputs. I'm going to add my push button now because I know I'm going to use it. So I'm going to go input PB1, and I'm going to make that equal to 7. And I'm going to also set another one, and I'm going to have to set that for the pot coming in here because I'm going to bring in this variable. And I want to set that up, so that's going to be pot 1. And that's going to equal A0 because I want to bring it in on the analog values. Now, I will tell you something that I did that I didn't explain yet. I connected my motor to pin 9. Pin 9 is capable of pulse width modulation. So you have to make sure you use on here on the board one of the pins that are for pulse width modulation. That includes pins 3, 5, 6, 9, 10, and 11 on the Arduino Uno. When I do this on the CircuitPython, almost every pin has pulse width modulation. So we're going to need pulse width modulation in order to vary the speed. So we're going to see how that works. So those are some of the things we're going to need in here. We're also going to have to add some variables in our program. But I don't know what those are yet, so let's not do those. Let's go down to our setup. So our setup is very simple this time. So we're going to put in here, and basically I'm just going to change this, the code that I want to run once. And this is, we're going to add in here is setup pin modes, because that's going to be important. We're going to have some of these pin modes set in here. So the first thing I want to set is that I want to set the pin mode for that motor, because I know I need the motor connected. So I can just type in pin mode. I'm going to write bracket, and I can just give it the name for the pin, which is motor 1. And I'm going to set it as an output, because that's what we're going to be doing, is we're going to be outputting to the motor. So that's our output. Our next line, what we're going to do is we're going to set up a pin mode. And this one is going to be for the input of the push button. So this is going to be PB1, comma, and this is no different than what we've set up in previous weeks here. So this is input underscore pull up. Because I don't like to add the external resistors, I like to use the internal that's already built into the board. So we always look for the opposite state. So we're going to use input pull up. So that takes care of our variables that, or our pin modes that we need to do. So now let's go have a look at what we need to put in the main program. So we're going to start in our main program by reading in any information we need. So what we have to do is we're going to have to read the input devices. And this is plural because we're going to have two here eventually. But we're going to start with the push button. So if I go with PB1, and I'm going to create a variable now called PB1 state, because I want to know whether the button's been pressed or not. So PB1 state is equal to, and basically this is just going to be reading the PB1 pin. So this is a digital read, and we're just going to put in the pin PB1. And that's it. It's going to read it. And what we're going to get is a true or a false value back from that. So we don't need anything more from that. So we just read it and we work from there. We continue on. So let's continue on. So we're just going to come down here and we're going to work with some simple program. So very simply what I'm going to do is I'm going to do something if I press the button and it's true. So I'm going to say if, and in this case here, I can put in the term PB if, and I'm going to say, oh, I need a bracket, not PB1. So not PB1 state, what I'm looking for is I'm looking for when it's not true. Because we used input pull up, the input's going to be, I like that. You're keeping me a running record to let me know that my audio is staying good. I'm happy for that. I'm not seeing the frame drop rate now, so maybe it finished updating in the background. I can only hope. So with not PB1 state, what I'm doing is I'm reading in this variable. So I'm reading it in, and I want to know when it's been pressed, which means it'll go false because I'll be taking the input and making it 0. So when it's false, I need to do something. So this is where I'm going to use my code. And I'm just going to create this. And it already indents for me, and it tells me, okay, now what do I want to put in here? Basically, what I'm going to do is if the motor run, I'm going to put in here motor run. So this is a new variable, equals not motor run. Basically, what I'm doing, I'm telling it here is take motor run. This one's rum. No, that comes later. The rum comes later. This is run right now. So motor run, I'm going to take it and I'm going to flip it to whatever the opposite value of what it currently is. So if it's true, I'm going to make it false. If it's false, I'm going to make it true. And what I'm going to do is I'm going to give that a little delay so it doesn't read the button too fast, gives me a chance to let go of it. And this is what we've been doing all along here with our push button. So this isn't anything new. This is basically it here. So what I've got here is I've got two new variables. I've created a variable here called PB1 state, which we're going to have to add up here in our variables. We're also going to have to add motor run. So why don't we do that now before we get any further? And then I can explain what we're going to do with that. Both of these values are Boolean values. So they are just a discrete either true or false. So what we're going to do is I'm going to put up here where this is, and I'm going to just type Boolean because I want to set it for a Boolean data type. And I'm just going to put those values in there. So this is PB1 state. And I don't need to set the state. I'm going to leave it alone because the program's going to change it back and forth anyway. So I don't need to give it a default value. And then I'm also going to add this Boolean. I'm going to add this for the motor run. So motor run is also going to be set by the program. Because I didn't give it anything, it'll start false. And it will always just toggle back and forth between false and true the whole time. So that's all I've done there. So now I have 3 pins and I have 2 variables that I've created. We'll have another one to add later. So let me just come down here. So the first thing we did is we looked at it, we read our input device, we look at PB1. Once we get PB1, if we press PB1, then change the state of motor run. Either turn it on or turn it off. Make it true or make it false. So now we actually have to set the motor so it actually starts. And this is where this comes in, just to toggle it basically on or off on the motor circuit. So down here, I'm going to put in an if statement. If motor run, so if motor run is true, I want to turn on the motor. It's as simple as that. So if motor, I'm going to say, hey, if the motor run is set to true, turn on the motor. And the way I'm going to do that is I'm going to have to digitally write to that motor value. So I'm going to go digital write, because basically I just want to turn that output pin on. Digital write, and I'm going to put it here. Digital write motor 1, because I'm going to do the pin. And what I'm going to do is I'm going to set it to true. And I got too many letters in there because true is not spelt that way. It's spelt like that instead. And I'm just going to say set it to true. That's going to turn it on. Now, something I need to do in here is, what if it's not true? If the motor run is false, I need to do something else. So this is the other half of an if statement. So what I've got here is, if motor run is true, digital write motor 1 true. Else, what I want to do is I want to go digital write motor 1, and I want to set it to false, which will turn it off. So now I've got 2 conditions. So this is our whole program right here. When I start the loop, I read the push button. Based on the state, if my push button is pressed, change the state of motor run. And then, depending if motor run is true or false, either turn the motor on, which is true, or turn it off, which is false. So let me hook up these wires, and then we're going to upload this in here, and we're going to give it a try. So first of all, we're going to take this motor. Now, I'm going to scroll back up here on my picture, because my motor is going to connect, my signal for my motor is going to connect to pin 9. So I'm going to take this one, and I'm going to connect it to pin 9, which is right there. I'm going to take my push button. Oh, look at that. I've got something in there because I have other things connected, which we won't talk about right now. There's another program in there running. And then I'm going to go take this one here, and I'm going to connect it to 7. So it's connected to 7. So here I go. I now have something happening in here. What I'm going to do is I'm going to validate this first. This would be nice to verify to make sure I didn't make any typing errors. And so far, hey, it looks like it's done compiling. So down here at the bottom of the page, it actually says done compiling, so it's happy. It's always good when the program's happy. So now what we're going to do is we're going to upload it, but I have to make sure I connect to the right one. And I am connected to COM3, and this board doesn't tell me like my other board did that it says Arduino. This is a one of the eBay knockoffs. with using the cheaper chip. So I have to know the COM port, and it is COM port 3 that it is connected to. So let me go ahead and upload this into this program, and then we'll try this. So I'm connected to this small motor up here. So we're going to see it go every time I press the push button here. So it's done uploading. If I press the button, my motor came on. And you can see it by the blur that it's going to be there doing it. Now, I guess the screen has to catch up. There we go. So I just saw it. I'm watching the delay as well. I wanted to make sure it's going. So if I press it again, the motor will stop. So with a single push button, I can start and stop this motor. And if you need to see it, it's just there. It's not connected any different than the other ones that we've done in previous weeks with connecting a motor. Press it, it starts. Press it again, it stops. Simple. We created the most simple start you can have. You might have a small fan that's running underneath a train layout, and you're using it to make the trees move or to make something move in the ground. And you could have it and just say, hey, I want it to turn on or off. And this is a simple way of doing that, turning it on or off. So hopefully that is still good there. Now what we're going to do is we're going to make it so I don't have to run it at full speed. Sometimes I really don't want to run it at full speed. So I'm going to make some changes here. And this is only one possible way of hooking this up. I want you to tell you that right now. I will need one more variable added to this. Actually, I need two more variables added to this. So I'm going to come up here to the variables, and we're going to add two variables in our program. I know what they are, but I'm going to add them so you can see them. So I'm going to say integer, and I'm going to put in here motor 1, and I'm going to put in raw. Because what happens on the analog value, if you remember from when we did a pot before, when we bring in an analog value, it comes in from 0 to 123. And when we output to the pulse width modulation to change the speed of something, it's actually 0 to 255. So we have to map it. So we have to bring the raw value in. So I'm going to say motor raw, and I'm going to say just leave it at that because it's going to get read, and we're going to get the raw value. And then I'm going to set an integer value for motor 1 value. And this is going to be a math calculation, so it's going to get done right away too. So those are going to be the two things we're going to do in here. We're going to start with this program, and we're going to have to read in the analog value, and then we're going to have to convert it to something that can be sent for pulse width modulation. So let's come down here to our program now. We read in the push button, so now we have to read in the value of the pot. So let me just do that here. So this is going to be motor 1 raw. So this is my raw value coming in, my 0 to 223, and that basically is equal to the analog read. And this time it's going to read pin A0 is what we want it to do, which was called pot 1. So that's our raw value coming in from 0 to 123. When we go down to the next line, we're going to convert this. And if you remember what we did, I'm going to do it here because this is motor 1 value, because we're going to change it to that pulse width modulation value. And we're going to make that equal to a function called map. And we did this before, but this is your refresher. So we're going to say we're going to map something. So the first thing is we have to give it the source of the map. The source of our map is motor 1 raw. We put in a comma, and then we have to set 4 numbers in here. We're going to set the minimum value for the input, which is 0. We're going to set the maximum value for the input, which is 123. We are going to set the minimum value for the output, which is also 0, and the maximum value for the output, which is 255. So that's what we're going to do there. So by doing this, I've taken that value from 0 to 1 to 1023 on my pot, and I'm converting it to 0 to 255, which I can write to the motor. So we can do a couple of things here. So what I'm going to go down here is we're going to do a simple one first. So what I had in here was if the motor is set to run, it said turn it on. Okay, so that's nice, that's true. But we can we can change that down here. So this is the true and the false statement. What we can do is we can actually do a couple of different things here. So instead of digital writing, what I can do here now is instead I can change it to an analog write. Analog write. And instead of using the value of true, I'm going to use my motor value that I created. So this would be motor 1 value. And guess what we're going to do with the next line here? What we can do here is I'm going to set it to a value of 0, but I'm going to change it to analog write as well. So all I did was change those digital writes to analog writes, and I've now gotten my motor value in there. So what's going to happen in here is when I upload this, and let's verify it before we upload it. Let's make sure it's happy. I didn't forget any semicolons, which are easy to do. And we're going to go ahead and upload this now. So I'm going to go ahead and upload this. And now what happens in here, it's all done, uploading. I'm going to set my pot for about halfway. And I'm going to push the button. And my motor starts up. So my button is still starting and stopping the motor. As I turn it up, it's going, and I turn it all the way to full, it goes to full speed. As I bring it down, I can slow that motor down, and it should still be visible on the screen there, that it's actually going quite a bit slower now. It's tricky to get the right spot, but you'll be able to see it slightly in there that it's going at a much slower speed. So it actually works. If I press the button, it'll shut off. If I go to start it though, it doesn't turn unless I give it a little help. So let's stop that again. What has to happen is you need a little bit extra voltage in order to get a motor to start. But now I can run at a slower speed. So this gives me the opportunity to take that same motor and adjust the speed of it, and I can still turn it on and off. And not quite enough. Bring it up a little bit. If I've done this right when I stop it, I can start it again and it'll pick back up. So I'm down to about the minimum setting I can do without having some other way to boost it. So that's one way of controlling this. There is a second way of controlling this, and I'll show that when I get to the CircuitPython. Now, I have this other motor here. Let's very quickly disconnect this motor that I'm using. So I'll take the red and the black off, move them out of the way. I'll take the red and the black from the other motor, and I'm going to hook it up. So now we can see there that it's turning. It turns at a fairly high speed, but I can slow this down, and I can get that down moving pretty slow. And the beauty of that is that this motor is a similar motor to this one. They're not identical, but they're similar. It's turning pretty fast, but this yellow box that's on it, this is a gear reduction motor. So I think this is moving like, I think this is like 220 to 1 ratio. It moves a lot slower than what the little tiny motor does. It's geared way down. But this is good if you want to add for robots. You could set this and you could put a pulley on here instead of this wheel here, and you could run it as running a funicular up and down a hill automatically on a continuous loop, like a tram, like they would in San Francisco. You can also use it for ski lifts and gondolas and all kinds of little animations within your train layout. And that's where it falls into the train layout idea. The problem I have with all of this circuit, no matter which one I'm doing here, which motor I'm controlling, this only goes in one direction. If you want two directions, you have to go to either the one of those driver boards I showed at the beginning. For those that have only seen this video, this is a driver board. This is a motor controller board. Gives you lots of flexibility. This is also another controller board for a particular type of board, plugs into it, and it has motor leads on it. Those motor leads can be connected and you have full control of the motors in forward and reverse. Or you can use another chip circuit. Let me pull that picture up on here for you just to show you on top. So what I'm going to do is very quickly, I want to show you this other image that I have on here. This other image is very similar to what we are connected to right now without the extra chip in the middle. This chip here, up in the top, is an L293D. This is a motor driver chip, and this actually has the ability to drive 2 motors on this chip. So the motor itself is connected to the chip. Both leads of the motor are connected to the chip. So these will do the small motors. They won't do big motors. They make big drivers for driving big motors. Or you use one of those other boards like I was showing to drive bigger motors. But what we have is we have 3 connections to the Arduino for this. One is telling it to turn on or off. One is setting the direction, and the other one is giving it a signal that gives it the pulse to tell it how fast to operate, just like we're controlling with the pot. So all of this is done here. We bring in external power, which is what it's showing down in the bottom right-hand corner of that image, and it brings it up and it connects it to the chip. So the chip is powered from the external, and it's also the common and the power are connected from the Arduino. So the Arduino is basically running this in here. This is also referred to as an H-bridge, if you've ever seen the H-bridge circuits and wondered what they are for motor controls. Basically what this is 4 of those other transistors, resistors, and diodes inside of a single chip. So I used a resistor, a diode, and a transistor on my board to make it run in one direction. If you want to run both directions, you need 4 transistors, 4 resistors, 4 diodes to handle all the backwash from this current, to handle the directions, and to be able to do all the rest of the controls. So it's all built into this chip already. So you don't have to use an external parts to do it. So that's how it's done to get motor speed control. So that's all it is to it. If you want motor speed control, get yourself an L293D. Look up the data sheet for it on Google, and you'll find lots of information on how to hook this up, plus this drawing here will do it. You can always review the video and then look at it again later. So this works, and this is a nice little way of doing it. Okay? So there's your nice little circuit there for your photo. So back to our program. So we can see that this is working. So I think because of the time we have here, I want to hook up the CircuitPython version of it, and I'll show you a slightly different way of doing it, and also how CircuitPython controls the motor using this same setup. So first thing I'm going to do is stop the motor. I'm going to go ahead and unplug everything from the Arduino Uno and move it out of the way. So I'm going to take its power and ground. I'm also going to take this lead, and this lead off of here. And there's my Uno. And now I got to try and untangle everything. This is always fun. Too much stuff in the way. I'll get that out of the way. Now let's bring this one in place. So here's my MicroPython version. So we'll just get those motor leads out of the way. On here we have our power. So we'll hook that up to the plus. We've got our ground, and we'll hook that up there. And before I hook up these other wires, I want to know where to hook them up to. So I'm going to bring in I'm going to bring up my other program. So this was the Arduino version. Very simple. Doesn't take a lot to control it, but you got some simple control of on and off for a motor. So now let's have a look at the version from CircuitPython. This is the CircuitPython version here. This one here, I've gone through. I have it. The big thing to note here is the analog value that comes in from the pot is a much larger resolution. It goes from 0 to 65,535. And it also has an output resolution from 0 to 32,767. So these are much bigger numbers than what we saw in the other ones there when we were playing with the Arduino Uno. The Arduino Uno went from 0 to 1023 for the input and 0 to 250 on the output. This was a much finer resolution. It's just the type of board and the type of way it does it. Doesn't do, not that it's any different, it's just, it is different, but not any significant way. Just a different resolution. Helper files, yes, are needed when we get into CircuitPython. So these helper files in this section right here, what happens is we have to include the board, which gives us our pin addresses. Time will allow us to create delays or timing features. Digital I/O, I need that because I'm going to be bringing in the digital pin for the push button. I need simple I/O, which is going to allow me to do some stuff in here. Pulse I/O is going to allow me to do the let's see, Pulse I/O is going to allow me to do pulse width modulation out. So that's what that's going to allow me. The math is used with simple I/O to do the mapping. So these two together are going to do my mapping, which is we did in the other program. And the analog is we're going to bring an analog value in, so we have to tell it that we're going to be using one of the pins as analog in. So now we go ahead and create those pins. In here I created PB1 again, the push button, and I've connected that to pin 9. So let me go over to the board, and I'm going to get my push button, which is the yellow wire, and I'm going to go ahead and connect it to pin location number 9. Just like that. So I hook that up where it says there. I also have my analog in value is the next one is InputPullup, just like we used before. It's a pull up, and it's going to be connected to that's the pin. Sorry, that's all for the push button, the first 3 lines. The next part, this line here, is the analog in value, and it tells me I'm going to connect to A5. So I'm going to go over here and I'm going to connect to A5, which I'm going to create a big shadow. And now that is connected to A5. So that's my analog output pin. I didn't use analog 0 in this one because this board actually has true analog out available on A0 and A1, which allows me to put out audio files, real audio files with a real speaker. So I kind of try to leave that one clear. And then finally, we're going to hook up our pulse width modulation pin in this case, and we're going to hook it to pin 10 for driving the motor. So we're going to go ahead and hook that to pin 10, which is right beside pin 9. So there's my 3 connections. This is no different than what we just did in the previous one. So it's the same type of thing. And if this is working right, somehow I don't think it is at the moment, but we're going to find out. So let's go through this program, because I don't see anything happening here. So it may not be happy at the moment, but we'll find out. We'll figure out what's going on here, because I still do have a motor connected to it. So we have motor run, and I think I know what happened here. I think playing around, I think it disconnected, reconnected, and these boards aren't happy when you do that. So I have a variable to create here called motor run, which is false, and let's have a look at our code. This is our code down here. So the code here is, while true, it says read the raw input value from the pot. So that's what I'm doing. I'm doing the same thing I did before. I got my raw input value. So I took that, and then this is the convert statement. Now this one's pretty long compared to the other one, but it's basically it's the map value is going to equal to the math truncated. In other words, get rid of any decimal points. We don't want decimal points in here, so that's why we had to include the map. And then we're going to use simple I/O to create this range, and that's the actual part of the map. That's the map function itself, called map range. Over here, I've created, it's basically the same as we did before. And what we have here is we have what is the input source, what's the minimum value for the input, the maximum value for the input. And if you notice, we don't go all the way to 0 and 62,553 or 57. It's because it can cause us some problems because the resolution's so fine. We have troubles reading 0 and the maximum. But we are going to set that to be the maximum for the output from 0. So if it gets to 1,000 or less, it'll be 0. If it gets to 62,000 or more, it'll be 32,767, which is full speed. So that's what's going to happen there. Now on the next line here, we look at our push button. If not push button, and it says motor equals not run. So we use the exclamation mark to make it flip. Here we use the word not. So that's all working the same with a little 500 millisecond delay, same as what we did if we press the button. Then it says turn on and off the motor. What I have here is if it's on, it says set the cycle to 32,767 because it's a pulse width modulation pin now. That's what I set it for. So it's going to set it to the maximum value. Else, it's going to set it to the mapping value, which is this one here. which is not working at the moment for some reason. And let's go have a look why. Oh, actually, it looks like I'm mapped. And I can go up and down. Now, let's see, what did we do different here? I think it's not working at the moment. Let me just do a save on here. And when I do, it's going to overwrite it, and there it is there. And it says right now I have motor run as false, so if I press the button, that changes to true. And I'm probably not plugged into analog 5. What did I do differently? I must have knocked a wire when I was playing with this. Let me unplug that motor. I'll just plug the other one in for the moment. I may have mixed up a wire somewhere or something. Who knows? It happens. Oh, that one's working. So we'll use the little one. We'll bring that in a little bit. I can adjust my pot now. I can see my mapping values going down. What's happened here to my mapping value? My mapping value is 0. I'm trying to look to see if I connected something to the wrong spot. Well, hopefully I didn't damage anything, but this should be varying the speed of it. But it doesn't seem to be at the moment. Not sure why. I'll have to have a look at it. I may have bumped something in my wiring without realizing it. Everything looks okay. I seem to be mapping my value okay. Well, we're still turning it on or off, so we're doing that. I'll have to look at the other, but hey, these things happen. I bumped something. I'm sure it's there. I don't think it's the program's fault. If I go back up to here and look at it, I should be able to see all this working. Yeah, come to the map value. Map value is there. It's calculating. It is creating a map value. And it's turning off, which is just going to 0. I might have to reset it. And I'm going to try that really quick. And it's always interesting to see how this resets, because you have to... This is Windows, so you make sure you eject it. It's telling me it's okay to unplug. I'm going to go ahead and plug it back in. My board has come back up live here. There it is. It's turning now. So I can see I've got slow speed there. So that's working. If I press the button, it'll turn on. It goes to high speed, so it turns faster. I press it again, it goes back down to the low speed. So it needed to be reset for some reason. Probably me moving it around. I probably bumped something I shouldn't have. So let me pull these two leads off. I'll dial this down to 0 first of all. I'm going to pull these two motor leads off, and let me try hooking up the big motor with the gear wheel, because it's easier to see. So if I've connected that properly, and I don't think I did. I may have accidentally broke a wire on the bottom of this motor, moving it around, but it's not happy. Or I'm just missing the pins. That one works, so we'll just stick with that. I can bring that down pretty slow. So there it is, running relatively slow. It should be visible in the video that it is running slow. If I press the button, we should see the speed pick up. It's gone much faster. And when I've done it, it's gone slow. So you could use this, for instance, if you want to use this type of circuit. This gives you something a little bit different. This allows you, when you turn it on, it goes up to full speed, and down the rest of the time it goes to slow speed. So you could actually have something that has 2 speeds on it, and just set the low speed to a fixed value, and then you can play around and you can make changes to adjust it for your layout. And maybe you have an area where you want something to go slow, and then at a certain point you want it to pick up speed. In theory, you could drive a train on a loop with this. You could have it start out low, and when it gets to a point, maybe you have a photo eye in there, one of the LDRs or an infrared sensor that we had. It picks that up, it tells it to go to full speed, lets the motor go to full speed, which would be your little train that's running on a closed loop. Runs fast train, runs around at a higher speed. When it gets to another point, it could trip another switch, tells it to go back to low speed, and it comes through a station or a set of crossings very slow, and then picks up speed again when it hits the next sensor. So you can do things like that. You can play around and use your imagination on how you want to control this. But as I've shown here, we can do some basic control where we can look after it and turn something just on or off, like we did in the first example. Or we could turn around and we can make it adjustable, and we can either make it adjustable and on and off, or we can have it go on, goes to full speed, off goes to the reduced pot speed. So lots and lots of choices for what you want to do here. And it looks like I didn't drop any more frames once I restarted. Not sure what that was about at the first time, but I'll make sure I get rid of that other video off of there. It looks like we've been running for a little shorter time than usual because of that problem in the start delay. But I've basically covered the circuit that I wanted to do. So I don't know if you have any other questions. The audio is either okay, or I put Walter to sleep. I'm not sure which it is, because I haven't seen any more comments from him after that. But I really appreciate you coming out and watching the show live. If you're getting this on the recording, I hope I still covered everything in the second run on it, because the first run got screwed up because there was something going on with the broadcast. So I restarted it, and I will make sure I get rid of that bad copy off of the internet and leave the good copy up there. So this is what's been happening. So that's motor controls. Keep it simple, play with it, don't be afraid to experiment. Don't forget you can have them just turn on and off, or if you want to be able to change directions, use either the L293D chip or buy one of the motor controller boards that are out there, and there are many, many, many boards out there for the different types of processors we use. And they don't have to be very expensive. They can be, depending on how big the motors are you want to drive. In reality, if you wanted to, you could run a real conveyor system using this as the base control and just driving a very large motor driver from it. So lots of choices out there. Hope you enjoyed this video. Yeah, all good now. Thank you, Walter. I appreciate that. Everything, I'm not showing any dropped frames again. Don't know what was going on at the beginning there, but hey, it's the internet and it's computers. What can I tell you? We know things go wrong, but we persevere and we try anyways. So I'd like to thank you for showing up. Next week I'll be back. I'm not sure what the topic's going to be yet. We're going to come up with something, and I'm going to see if I can start working on a train project. It might take a couple of weeks to do. I'm waiting for some parts to come in, and if they show up, when that shows up, we're going to be going on to a train project, but I won't tell you what that is until we get the parts. All right, but we will have something for you next week. Thanks very much for dropping by. Remember, I'm kingernorth. Microcontrollers with kingernorth. Spread the news, let other people know. This was episode 13, so there's 12 other episodes on the my YouTube channel for you to follow or watch. You can always get information on this and get notifications by turning on your notifications and subscribing to me on YouTube at youtube.com kingernorth, or you can get your notices from via Twitter. Just look me up and follow me at kingernorth. So until next time, thank you very much, and I hope you enjoyed the show.